Welcome back to Object-Oriented Programming 1. In our previous lesson, we explored the concept of object-oriented programming. We learned that object-oriented programming is a programming paradigm that models real-world objects inside computer programs. We also discussed that every object has properties which store information, and methods which define the actions that an object can perform. Understanding these concepts is important because they provide the foundation for writing object-oriented programs. Today, we will move from theory to actual programming. We will learn how to create classes, construct objects, assign values to properties, and define methods using JavaScript. By the end of this lesson, you will be able to build your first object-oriented program from scratch. Before writing any JavaScript code, we first prepare a simple HTML document. This document serves as the environment where our JavaScript program will run. Inside the body element, we create a script tag. Everything related to our object-oriented programming lesson will be written inside this section. When the HTML file is opened in a web browser, the browser reads the JavaScript code inside the script tag and executes it automatically. This setup is lightweight, requires no additional software, and is an excellent environment for beginners learning JavaScript. The first step in object-oriented programming is creating a class. In JavaScript, a class is declared using the class keyword followed by the class name. In this example, the class is named student. A class is simply a blueprint. At this stage, it does not contain any data or behavior. It only defines the structure that future objects will follow. Think of a class as an architectural blueprint. Before a house is built, the blueprint describes its design. Similarly, before an object is created, the class defines what that object will look like. Although this class is currently empty, it forms the foundation of every student object that we will create later. Now that we have created a class, we need a way to give each object its own information. This is where the constructor comes in. A constructor is a special method that runs automatically whenever a new object is created. Its purpose is to initialize the object's data. In this example, the constructor accepts three values: name, age, and course. Inside the constructor, the keyword this refers to the object currently being created. When we write this .name = name, JavaScript stores the value provided during object creation into the object's name property. The same process is repeated for age and course. This allows every student object to contain its own unique information while still following the same class structure. With the class complete, we can now create actual objects. The keyword new tells JavaScript to create a new instance of the student class. The first object is assigned to the variable student1 and contains the values John, 18, and Bipsit. The second object is assigned to student2 with the values Maria, 19, and BSCS. Although both objects were created from the same class, each object stores different information. This demonstrates one of the greatest strengths of object-oriented programming. A single class can be reused to create many independent objects. To verify that our objects have been created successfully, we use console.log. This function displays the contents of an object inside the browser's developer console. After running the program and opening the browser's developer tools, we can inspect each object and see its properties and their assigned values. This is an important debugging technique because it allows programmers to examine the data stored inside an object. Objects contain multiple pieces of information called properties. To access a specific property, JavaScript uses dot notation. The syntax consists of the object name, followed by a period, followed by the property name. For example, student1.name retrieves the value stored inside the name property of the student1 object. Likewise, student1.age returns the student's age, and student1.course returns the course. This simple syntax allows programmers to retrieve and use data stored inside objects throughout a program. Objects do more than store information. They can also perform actions. In object-oriented programming, these actions are represented by methods. Here, we create a method named introduces. Inside the method, we use template literals to combine text with the object's properties. Notice that the method accesses the object's own data using this .name, this .age, and this .course. Every object created from this class can use the same method while producing different output based on its own data. This demonstrates how methods allow objects to behave intelligently while reusing the same code. After defining the method, we can execute it by calling it through an object. The syntax is the object name followed by a period, then the method name followed by parentheses. When student1.introduce is executed, the program displays John's information. When student2.introduce is executed, the same method runs again. But this time it uses Maria's information. Although the code is identical, each object produces different output because each object contains different property values. This is one of the key advantages of object-oriented programming. One method can be reused by many objects. At this point, we have successfully created a complete object-oriented JavaScript program. We started by creating a class, then added a constructor to initialize data. Next, we created multiple objects using the new keyword, accessed their properties using dot notation, and defined a method that allows each object to introduce itself. Although this example is simple, it demonstrates the fundamental workflow used in almost every object-oriented application, from small web projects to large enterprise systems. As we continue our journey through object-oriented programming, we will build these concepts by learning how to protect data with encapsulation, inherit features from other classes, and create flexible programs using polymorphism.